Our next talk is Dominic Halsmer, introducing earth science students to science and faith issues using reverse engineering. All set for all of you engineers in the room. Dom, go for it.
Thank you, Lynn. I have been enjoying a sabbatical project and working with some students on developing some curriculum. It's been really fun. One of the students that I have worked with was going to be here this year, but she's from South America. She's an engineering student at ORU, and her name is Dominica Baez. But she couldn't make it all the way from South America, a little too expensive. Hopefully next year, when we have our meeting in Washington, D.C., she could make it, because I expect her to continue to help me with these projects, and she would benefit a lot from the experience. It all started when the dean of the College of Education at ORU, Kim Boyd, came into one of our college meetings, College of Science and Engineering, and said, our teacher candidates, our education majors, take your gen ed science courses like physical science and earth science, and our accreditation board has told us we need to bring more engineering ideas and principles and topics into the K-12 environment when we send our teacher candidates, our graduates, our education majors into that environment. Can you help us bring some engineering content into your gen ed science courses? And I immediately thought of, because I was teaching earth science at the time, oh yeah, you could do a lot with earth science, bringing some engineering concepts in. And what's in particular been fun about this is trying to write about engineering so that non-engineers can grab a hold of it and understand it and run with it, and then demonstrate it and do hands-on experiences with it with K-12 students. So it's really been a fun project, and it's still a work in progress. I don't have any data about how well it's working yet because I'm still writing it. But I do teach this earth science course. This is the textbook I use for both the lecture and then the lab. And the idea is to develop engineering-related labs. Not so much that we're going to modify the lectures, but in the labs, we're going to have hands-on experiments and experiences for these gen ed college students, many of them education majors, so that they can take some of this material into the K-12 environment and hopefully get more students in the K-12 environment interested in engineering. Some other students that have been helping me with this is an education grad student, Jasmine Marco, in working out exactly what the requirements are for the education curriculum. And then Chris Jacob and Josiah Kessler, a couple of other engineering students who have also been helping me with this project. And then I got my entire applied thermodynamics class to think about this topic. Towards the end of one semester in applied thermo, I said, okay, I got a project for you. I want you to develop some simple lab experiments. And I actually told them about the project that I was working on. This is going to be for the earth science course so that education majors can take these projects and take them into the K-12 environment. And let's see what you can come up with. So they did things, that was pretty cool stuff. And it was a fun little project for them that incorporated some of the stuff we were doing in applied thermo, like wind turbines to bring in the concept of efficiency. You know, you have a certain amount of energy going into the wind turbine, and then a certain amount is generating electricity. So then you can introduce the simple concept of efficiency, how much energy you're actually getting out of this wind system. One team built a steam engine out of a Pepsi bottle and operated it on the stream on our campus. Thought that was pretty interesting, but they've got an open flame there, so I'm not sure how good that would be to take into the K-12 environment. They'd have fun, though, that's right. And that's a big part of it, Lynn. Solar-powered fan. And one guy had the idea to demonstrate how we model things in engineering by looking at the friction involved in plate tectonics. And even though this was a really simple little project involving friction, to demonstrate how plate tectonics works with friction and release of friction, I think this has a lot of potential for a more detailed lab. But the lab I want to talk about today, that's just kind of a lead up to this, would be the last lab in the manual for these earth science students. And it would be a virtual lab because it would introduce the idea of reverse engineering. Many of you know I'm interested in this topic, and especially how we apply reverse engineering, a reverse engineering approach to natural systems. One way to describe this is as a retrodictive thought experiment. Retrodictive means you're going to look at how things are and then try to think backwards and explain how they got that way, and maybe even some other deeper questions, answer some deeper questions. To explore the origin, but not just the origin, how the Earth came about, how old the Earth is, but also the nature of planet Earth, because it is, as far as we can tell so far, it's a pretty unique place. And then it's not going to be limited to science. I want to blur the lines between science and philosophy now, and even theology. And this is designed initially for a Christian college and Christian students, or students at a Christian college or university, but I'm intrigued with the idea that I might be able to extend this and make it palatable and interesting to non-Christian institutions as well. But that's the idea. This final lab in the set of lab experiences would be an introduction to reverse engineering, and the specimen that we would look at would be the planet. But you know, it's hard to keep it to just the planet because the planet Earth is not in isolation from everything else in the universe. And there's an entire story behind how the Earth came into being, which includes everything from the Big Bang, which is so fascinating. It's such a fascinating part of the story. So the challenge is to try to fit this into a 3-hour lab. So I'm working on that. I call it Hacking the Earth, a virtual reverse engineering approach to uncovering the secrets behind the amazing habitability of our home planet. Now, you might think right up front, how in the world can you apply reverse engineering to a natural system and talk about teleology of natural systems? And they're not even biological systems. You're talking about a rocky planet here. Okay, it has biological systems on it, but the Earth itself is non-living. How can you talk about teleology of a non-living system? Well, I found a really interesting paper that just came up last year, actually came out this year in March, Teleology and Function in Non-Living Nature by Gunnar Babcock. And he uses McShay's field theoretic account of teleology, which says, look, if there is a field, and you can think simply of a gravitational field in which certain things tend to an end, like a ball in a bowl will tend to the bottom of the bowl. And in the sense that they're talking about here, they see that as teleological. It tends towards some end. So I think this is a really interesting way of looking at natural systems and talking about them in terms of teleology. And you can read that paper if you're interested, but he goes on to say that different aspects of nature have different levels of teleology. You might know that I wrote a book in 2019 called Hacking the Cosmos, and so this is kind of an extension of that work. The subtitle there is How Reverse Engineering Uncovers Organization, Ingenuity, and the Care of a Maker. It looks at affordance-based reverse engineering of both artificial and natural systems, and affordances are simply relationships that provide an end user with some potential action. You have the chair you're in affords sitting. It's really simple idea. But with complex systems, you have lots of part-to-part relationships or affordances that ultimately lead to an end-user affordance. So this gets into the complexity of these natural systems. It helps us to think through them. And then finally, I look at practical and philosophical implications. And if you want more information on my approach to reverse engineering as an exploratory problem solving methodology, you can look at this book edited by Chuck Bockel, Mechanical Engineering Education Handbook. We wrote a chapter in there on the philosophy of reverse engineering. And this is related to the idea of philosophical cosmology, which a recent book on this talks about how this tries to respond to questions like, what is the origin and meaning of the cosmos? How does the cosmos behave? What are its essential constituents? Does the cosmos have an ulterior motive? How can we understand the cosmos in which we find ourselves? And like I said, when you think about the Earth, you can't help but extend that investigation to include how the Earth came about. And that's going to lead you to thinking about the cosmos itself. But you could actually ask these things about the Earth as well. This is also related to some work that George Ellis has been writing about in some recent posts. He's a Templeton Prize winner, if you don't know, very, very famous physicist. He's been talking about these possibility spaces. And I see this as very, very much related to this idea of the universe being a system of interdependent nested affordances. That is, part-to-part relationships that lead ultimately to an agent being able to make a decision to gain possible situations or spaces to enter into. These nested affordances lead to and sustain complex life in the universe. And again, an affordance is simply a relationship that offers a potential capability or a choice that an agent can make within the system. And they can be either positive or negative. But see, possibility spaces are just the result of these nested layers of affordances throughout the history and space of the universe. If you're interested in what George Ellis has to say about these possibility spaces, look at the Philosophical Problems in Cosmology, a deep dive into the foundations of cosmology back in 21. If you're interested more in affordance-based thinking, affordance-based design, affordance-based reverse engineering, it's Jonathan Meyer who's written the book there. He was a researcher in the engineering department at Clemson. Proposed that the concept of affordance, what a system provides to an end user as a potential action they can take, or to another part of the system, that would be the part-to-part affordance. This is an underlying and unifying principle in the science of product design, but also in reverse engineering. And this is what I've adopted as my recommended methodology for this kind of thought experiment on the Earth. And the fact that engineers create affordances, a simple example would be a smartphone has tons of part-to-part affordances that ultimately lead to end-user affordances. Every single app you have on here is an end-user affordance. And that's what engineers do. They create affordances. That's why Meyer wrote the book on affordance-based design. What you try to do is maximize the number of positive affordances when you do affordance-based design and minimize the number of negative affordances. And so I would suggest that a reasonable hypothesis, since the universe has these layers and layers of nested affordances in both space and time, a reasonable hypothesis would be that the universe is an engineered system. And this is one you would explore. You could explore this hypothesis as we explore the evidence for the nature and origin of our Earth. And this is what I'm suggesting in our lab. And this turns out, I think, to be an interesting way, or I hope it'll be interesting to the students, an interesting way to introduce science and faith issues to them. Things like the age of the Earth, the evidence for evolution, the evidence for an ancient universe, these kinds of things. So what would be the features of this virtual lab experience? Like I said, I'm initially writing it for our Earth Science course at ORU, but I would hope that I could write it in such a way that others would be interested in it, even secular schools would be interested in it, hopefully, because they would at least recognize that many of their students have these religious viewpoints, and this would be one way to help them think about how that fits together with the scientific evidence. It certainly includes both scientific and philosophical considerations, but I think that's where things get the most interesting. I know it's a science course, but the philosophical implications are what really are of concern to humans. So we approach it with a reverse engineering mindset. We would introduce that at the beginning and justify that mindset by talking about the affordances within natural systems. And one thing I want to try to get at is to help the students think a little bit deeper about the presuppositions that they bring to this course and this experience. Because this could challenge young earth creationists to reconsider, but it could also challenge atheists to reconsider their worldviews, and everybody in between. I'm going to try not to tell them what to think, but hopefully get them to dig into the evidence and see what they think from all of the evidence, from all different pertinent fields of knowledge. The emphasis would be on critical thinking and maintaining objectivity, avoiding bias. And one of my students did a little work on guarding against bias, being aware of egocentric and sociocentric tendencies. And here we're getting into intellectual humility, too. I hope to teach them something at the start of this about intellectual humility. You craft the method of your investigation with objectivity in mind. That is how data is acquired and how hypotheses are evaluated. You make your worldview and method public. You open yourself up to scrutiny of peers. I appreciated that about Hugh Ross was talking about doing that when he invited atheists and skeptics to come in and critique their testable creation model. Present your ideas to experts who hold contrary views and see what their input is. Consider the pertinent historical bedrock, and what they mean here is statements that have a significant amount of evidential support and are taken as facts by the vast majority of critical scholars in the field. So this is one way that you can try to avoid bias as much as possible and be aware of it as you're looking at all of the evidence. So the learning objectives are to describe methods of retrodictive thought experiments and reverse engineering so the students can understand the approach that we're taking. Summarize the process by which planet Earth came about and the governing laws. These are what the students ought to be able to do by the end of this experience. Describe and assess the measurements for determining the age of the Earth, such as paleomagnetics. Explain fine-tuning for life and its relation to evolution. At that point, I'm hoping that the students can think through the possibility and entertain the possibility that perhaps, as Rob Kayonen has recently written in his book, there is a compatibility between evolution and design that we might consider. I would have to define affordance and explain how it relates to the reverse engineering methodology, and hopefully they would be able to do that by the end of this experience. Summarize Earth's climate issue and how this relates to stewardship as an example. Describe the 6 common models of origins, and then explain how differences between scientific and religious perspectives might be reconciled. And that last point is one of the things I really want to get at, is have the students hopefully have an aha experience where they don't have to decide between scientific and religious perspectives. That's it. That's all. Just that in 3 hours of lab experience.
Okay. Let's thank Don.
Could you give us a sort of brief overview of just exactly what the students will do in those 3 hours?
Yeah.
Or will they have done 3 months worth ahead of time?
So one of the nice things about this lab experience is it will draw from the lecture material, because in the lecture, in the Earth Science lecture, we cover paleomagnetism, which allows us to get a handle on how fast the continents were spreading. And this leads into a date for the age of the Earth. And then there's other evidences in the Earth Science lecture on the age of the Earth. So they don't have to reproduce all of that evidence or dig into it on the internet, although there will be some internet digging during this experience. But they will be gathering information to try to answer some of the questions that come up on the origin of the Earth, the age of the Earth, and the fine-tuning of the Earth and the habitability of the Earth. So they'll be doing a lot of digging for information in a virtual way on the internet. And but then they'll also be in conversation in their small groups, their lab groups. And I'm envisioning that there might be a very diverse lab group with an atheist, an agnostic, a young earth creationist, an old earth creationist, and an evolutionary creationist. So that could be a really, hopefully, a rich discussion if they are intellectually humble and respectful, which is something I want to introduce at the beginning. So hopefully that's the kind of thing that'll go on in the lab.
Thank you. I appreciate the pedagogy, but my question is this. If you regard the universe as an engineered system, are you a normalist or an abnormalist?
Well, that's a good question. An abnormalist in the sense that whenever you do a reverse engineering a project, you have to consider the fact that your specimen may have undergone some wear and tear, some damage, or is it a pristine specimen right off the assembly line? And in our case, I don't think we have a pristine, perfect specimen. It has undergone some corruption.
Thank you.
I have a previous paper on that topic, so appreciate that question. It was an easy one.
Dominic, I find as I create new curriculum and the goal is to change the students, I find that I'm also changed. So I'm curious as to what your involvement with reverse engineering, which you've been doing for a while, has impacted your own interpretation of things.
That's a great question, Bill. Well, I know I've enjoyed writing, trying to bring engineering principles to the level of the gen ed science student who has not had engineering courses. And I hope that has made me a better communicator and thinker in terms of keeping things simple. As an example, we see, interestingly enough, we see control systems within nature, not only in biological systems, but the algae cloud albedo feedback mechanism is a control system that helps to keep the temperature nice on Earth. And I thought, how can I demonstrate a control system with these students? Well, you can set up an entire system where you have a camera that does vision and, an inverted pendulum on a cart which drives back and forth and keeps it stable, because I wanted to illustrate the concept of stability, right? But that's so complex. And then I thought, why not just have them take a meter stick on their hand and balance it on their hand? They are the controller. And that's the control system is within them. And they get an immediate understanding of control systems. And then you let them do it with a shorter stick and an even shorter stick. And then eventually they come to some interesting conclusions about the capabilities of them as a control system. So I feel like I've learned a lot as I've been trying to develop these kinds of hands-on experiences for them.
Dominic, I was just going to ask, what's the end product? Is it like a worksheet?
Yeah, it's a lab.
Write a report?
Well, it will be, this particular unit will be the last unit in a lab manual on engineering principles of earth science. And so, I'm working on developing that lab manual, and hopefully ORU Press will publish it. Hey, Bob.
Hi, Dom. When we had the ASA meeting at ORU, 2015, I believe it was. We had a great geology field trip as one of the field trips. Have you thought about working in some field stuff with this work that you're doing? Because there's things nearby.
That is a great idea. I'm writing that down. Bob?
Very interesting project, Dominic. I'm familiar with dependencies in a computer science context, and it sounds very similar to affordances.
Yeah.
This is going the other way. And I'm wondering, is it exactly the same? Is there a reason the engineers prefer to go the other way?
No, it's not the same. Affordances, the concept of an affordance comes from James Gibson in ecological psychology in terms of an agent and an environment, whether it's an animal or human in a certain environment. They have certain affordances within their environment, which are relationships between them. An affordance specifically is a relationship that leads to an ultimate or potential action that can be taken. So that's how they define it in ecological psychology. Now engineers have extended that definition, but it's not technically correct to say that it's a dependency. I may have been talking like it was a dependency, but ecological psychologists will tell you it's a relationship between an agent and the environment. But I really think it's a helpful concept in doing reverse engineering of natural systems, is to identify those key relationships that lead to an end user capability.
Okay, thank you very much, Dom.
Thanks.